In this video lesson, we have a practice question on the resolution of vectors. And the question is, an object is acted upon by two forces, 5 Newton and 12 Newton. Calculate the resultant of the two forces if the first condition says that the forces act perpendicular to each other. The second is if the two forces act at an angle of 40 degrees to each other. And then the third is if the two forces act at an angle of 125 degrees to each other. So we have two vectors that are acting at different conditions or at different angles to one another. So let's begin with the first one. In the first case, we have the two vectors 5 Newton and 12 Newton acting perpendicular to each other. And perpendicular simply means at right angle or at 90 degrees. So we are going to take the resultant along this point. So we have this as the resultant arrow. So when we close up this, we are going to have this triangle. So if this side is 5 Newton, automatically this other side is also 5 Newton. And for vectors that are actually perpendicular, we simply apply the Pythagoras formula. So in this case, we have h square, which is the hypotenuse square, is equal to the opposite square plus adjacent square. But we can modify it to be the resultant square is equal to the force acting along the x-axis plus the force acting along the y-axis or the y direction. So in this case, our resultant square will be, now this is the force acting along the f. So that's the force acting along the x-axis. So this right here is the force acting along the y-axis. So the fx is 12 square plus the fy is 5 square. Now 12 square will give us 144 plus 5 square give us 25. Now when we add up 144 and 45, we are going to end up having 169. So we are going to take this square to this other side. So arrow is going to be the square root of 169, because when this square moves to the other side, it's going to be the square root. So the square root of 169 is simply 13 Newton. But this is just the resultant in magnitude. We're also going to calculate the direction of the resultant. And remember, for direction of the resultant, we use simply this formula. Theta is simply the tan inverse of the vector acting along the y over the vector acting along the x. So it's simply fx over fy, or simply remember differentiation where you have the y over the x. So it's vector along the y over the vector along the x. So in this case, theta will be the tan inverse of fy. In this case is 5 Newton. So we have this to be 5 Newton over fx is 12 Newton. So we have that to be 5 Newton, and then we have the other to be 12 Newton. So we have this to be theta is equal to tan inverse of 5 divided by 12, and that will give us 0.4167. So when we take the tan inverse from our calculator, we are going to end up having an approximate value of 22.6 degrees. So remember, this is the angle between this resultant and the horizontal. So this value is 22.6 degrees. So that is the value of the resultant. This is the value in magnitude. So this is the value right here in direction. So your answer is simply 13 Newton, 22.6 degrees. In the second case, we have to look for the resultant when the two forces act at an angle of 40 degrees to each other. So in the second case, we have these two forces, 5 Newton and 12 Newton, acting at an angle of 40 degrees to one another. For any case where we have two vectors acting at any angle that is not at 90 degrees and are not parallel, we simply apply the parallelogram's law of vector addition. So I'm going to close this to have a parallelogram. So then I'm going to take my resultant. This is simply going to be our resultant. So if this side is 5 Newton, then this side will also be 5 Newton, the opposite side. So we have this as the resultant. And then to get this angle, we are simply going to subtract this 40 from 180. So 180 minus 40 will give us 140 degrees. So this is 140 degrees. So we are going to apply the parallelogram's formula, the cosine rule. So that formula is r square is equal to p square plus q square minus 2 PQ cos theta. So we don't have that. So now arrow square is going to be P, which is 5 square, plus Q, which is 12 square, minus 2 times 5 times 12 cos 140 degree. So 5 square will give us 25. So we have this as 25, and then we have this as 144, minus 2 times 5 times 12 will give us 120. Cos 40, now the value of cos 40 is a minus 0.7666. So now arrow square will simply be 25 plus 144, that will give us 169. Remember to add just these two together first. Now minus 120 times minus, because bracket means minus, so minus 120 times minus 0.766 will give us a plus 91.93. And then this value will end up giving us 260.93. So we have arrow square to be 260.93. So you're simply going to take the square to this side, making the square root, so arrow will be the square root of 260.93. And then this value, when we take the square, it gives us 16.15 Newton. So this is the resultant in magnitude. So we then go ahead to calculate that for direction. Remember, I told you in the previous video lesson, we have to cut out that triangle. So I'm going to cut out this part. So I'm going to take out this part. I'm going to take out just this part. So we end up having something like this. So remember, this is 140. Now this is 12 Newton. From calculation, we got this resultant to be 16.15. And then this is 5 Newton. And remember, we are interested in this angle, theta. Same thing here, theta, the angle between the resultant and the horizontal. So like I told you, pair a side that is complete. So now this side is complete. So I'll simply say 16.15 over sine 140 is equal to, now pair the side that you are looking for with the opposite side. So we have 5 over sine theta. So now we are then going to go ahead and then make a calculation. So sine 40, or we have this will be 16.15 over sine 40 will give us 0.643 is equal to 5 over sine theta. So we'll cross multiply. Now 16.15 here times sine theta here will give us 16.15 sine theta. So we are then going to have 0.643 times 5. So we're going to have that as 5 times 0.643. So we are going to divide both sides by 16.15, as the case would be 16.15. So we now have it as sine theta will be 5 times 0.643 over 16.15, and that will give us is 0.199. So when we take sine to this other side, theta will be the sine inverse of 0.199. So the sine inverse of 0.199 is approximately 11.48 degree. So this is the resultant in direction. So for the C part is when the two forces are acting at an angle of 125 degrees to each other. So for this case, we have these two vectors, 5 Newton and 12 Newton, acting at an angle of 125 degrees to each other. Again, this follows the parallelogram's law of vector addition. We are going to end up having something like this. So when we take our resultant, which is going to be something around here, so we can have this as arrow. Now remember, this angle we need must face the resultant. So this is theta. So to get theta, we are simply going to say 180 minus that angle between both of them, which is 125 degrees. So therefore, theta will be 180 minus 125, and that will give us 55 degrees. So the angle we need in solving is 55 degrees. So we are going to apply the parallelogram's law of vector addition, which we have here to be arrow square is equal to p square plus q square minus 2pq cos theta. So again, r square would be p, let's take that as 5 square, plus q 12 square, minus 2 times p, which is 5, times q, which is 12, cos the angle opposite to the resultant is 55 degree. So now r square will be 5 square is 25, plus 12 square is 144, minus 2 times 5 times 12 will give us 120. So the value of cos 55 is 0.574. So we have r square to be equals to 25 plus 144 give us 169, minus 120 times, because the bracket means times, 0.574 will give us a 68.88. So when we subtract, r square will be 100.1. So we are going to take this square to this side. It's going to be a square root. So r will be the square root of 100.1. Therefore, the final answer, r will be 10 Newton. But remember, this is the resultant in magnitude. So now let's go ahead and calculate the resultant in direction. So we are going to cut out this part, this particular part from this parallelogram. We are going to cut out this particular triangle. So we are going to have something like this. So we have this as 12 Newton. So we have this side as 5 Newton. And then our resultant from calculation is 10 Newton. So we had this angle before to be 55 degree. Now remember, we are looking for the angle between this resultant here and this horizontal down here. So we are automatically looking for this particular angle theta. So like I said earlier, pair a side that is complete. So by pairing, we are going to have 10 over sine 55 is equal to this side 5 over sine theta. So now we have 10 over sine 55, which will give us 0.819 is equal to 5 over sine theta. So from here, you do what you cross multiply. So we are going to have this 10 times sine theta. So that will give us 10 sine theta is equal to 5 times 0.819. So we are going to have it as 5 times 0.819. So the next thing we are going to do is that we are going to divide both sides by 10. So we now have this to be sine theta is equal to 5 times 0.819 over 10. And when we multiply and divide, we are going to end up having 0.4095. So theta will be the sine inverse of this value, and the value there is 0.4095. So therefore, the sine inverse of 0.4095 will give us an approximate value of 24.17 degree. So this is the value of the resultant in direction. So in magnitude, it is 10 Newton. The direction is 24.17 degrees. So this is the final answer. So viewers, I hope you enjoyed this video lesson and you learned something on the resolution of vectors. Don't forget to click on the like button and also do it to share the video lesson with your friends. And also, if you haven't subscribed to this channel, do it to hit the subscription button and turn on the notification bell so that whenever I release a new video, you will always get notified. See you in the next video.